Alrighty. Oh, Peter. Um, Welcome to Noon's Law of Cooling. Yay! If you haven't already, make sure that you have watched logistic models first before you attempt this lesson, just because there is lots of similarity going on. Noon's Law of Cooling is just an additional step that we need. So, let's get to it. Make sure that you have this lovely formula right here. You will not be given this formula, meaning that you have to memorize it. Unfortunately, I know, sad. We have T of T, so this is going to represent the temperature after T minutes. So this is your final temperature of the hot object. T sub M is the temperature of the medium. In other words, the surrounding temperature. And 99% of the time, it's going to be the room temperature or the air, whatever that is. T sub 0 is the initial temperature of the hot object. T sub n, once again, is the temperature of the surrounding object. Then we have e to the negative kt. K is your decay constant. And then T represents time in minutes. Okay. So, Mr. K hears some gossip and makes some hot tea to sip. The initial temperature of the tea was 92 degrees Celsius, and he forgets about the hot tea because the other tea was hot and juicy. So after 12 minutes, the temperature was 50 degrees Celsius. Given that the temperature of the room was 22 degrees Celsius, how long will the cup take to cool down to 30 degrees Celsius? All right, so we have our lovely formula. T of T is equal to T sub M plus T sub 0 minus T sub M e to the negative kt. So what does each thing mean? T of T is your ending value, so the ending value was 50 degrees Celsius. Okay. T sub n is the temperature of the medium, aka the surrounding temperature. And in this case, the surrounding temperature was 22 degrees. So I have 22 right here, and then I have 22 right here. T sub 0 is going to be the initial temperature, which is 92 degrees. And time is 12 minutes. So from the time it took initially to the time, or from the temperature of the initial T being 92, and then from the temperature being 50 minutes after 12 minutes would be our time. Negative 12K. I'm going to write negative 12K. All right. So now that we know everything, we need to figure out what K is because that is my decay constant. And after we find K, we're going to use that K value to find a T whenever we have a cup of 30 degrees. I am going to subtract 22 on both sides, so that's going to give me 28. I'm also going to simplify the 92 and 22, which is going to give me 70. So now I have 28 is equal to 70e to the negative 12k, which honestly isn't that bad of an equation. You're just going to divide by 70. So now I have 28 over 70 is equal to e to the negative 12k. I'm going to take the ln of both sides. And then I'm going to divide by negative 12 to solve for k. So now that I have that, I have ln of 28 over 70 over negative 12. What you want to do now before you do anything else is store this value into your calculator. So you want to store this in the calc. In order to do that, if I were to go to my lovely bootleg 84, I am going to type in ln of 28 over 70, and then that's divided by -12. I am going to hit the STO button, and this STO button on your 84 is above the on button. So right there. And in this case, it's above my settings. And then you are going to press X, which is your variable button, which is below mode. And this is going to give us the stored value as X, or K in the other case. Now we're going to go back to the problem. And we're essentially doing the same equation, except this time, my temperature isn't 50. I want to figure out what my temperature is for 30. So that means that this is 30. I don't know what my K value is. No, never mind. I don't know what my T value is, but I do know what K is, because K is my lovely thing that I just found earlier. We are solving for T now. If I'm going to solve for T, I'm going to subtract 22. That's going to give me 8 is equal to 70. E to the negative KT. I'm going to divide by 70. Is equal to 8 over 70 is equal to e to the negative KT. I'm going to take the ln of both sides. Now, remember, even though I have two variables, that's okay, because I already know what K is. K is the thing that we stored earlier, so I'm just going to divide that by negative K, because I want to find out what T is. So, your final answer is ln 8 over 70 divided by negative K. Well, what is that? Well, put this into the calculator. We have ln 8 over 70, and we're going to divide that by negative x, which gives us about 28.41 minutes. This means that after 28.41 minutes, my hot tea of 92 degrees has cooled down to 30 degrees. So you should probably see a little bit of the similarity between logistic growth and Newton's law, because the only additional thing that we're doing is after we find that K value, we're going to plug in that K value, and then we're going to try to solve for T. Okay, number 2. Good news to my boba lovers, especially Saturday. I don't know when they announced it, I forgot. But over the weekend they announced that Boba Baba will have mochi donuts every single day. And how to celebrate it? By making a problem out of it, of course. Why not? So let's say that the pastry chef removes the mochi donuts from a deep fryer of 350 degrees Fahrenheit, and it cools down to 120 degrees Fahrenheit after 20 minutes in a room of 65 degrees Fahrenheit. I need to figure out how long would the donuts take to cool down to 90 degrees Fahrenheit. So, essentially, we're doing the same thing here. And we're going to see what we know in terms of this problem. Highlight what you know. So we know that T of T is going to be 120 degrees Fahrenheit. So that is my end goal for the first part. T sub M is my medium, aka the temperature surrounding the cooling. And in this case, it's going to be 65 degrees. So 65. T sub 0 is going to be... Ooh, nope, that's not good. Why do I have trouble picking a highlighter? T sub 0 is 350 degrees. So that's 350. My surrounding temperature is 65. And then it takes 20 minutes for the donuts to cool down. I want to find out what K is. So guess what? We're solving for K. I am going to subtract 120 and 65. That's going to give me 55 on the left. If I simplify 350 and 65, that's going to give me 285. Then I have e to the negative 12k. Divide by 285 on both sides. So now I have 55 over 285 is equal to e to the negative 12k. Take the ln of both sides. And then divide by negative 12. So now we get, congratulations, the k value. Yay. Are we done? Unfortunately, no. In this case, we're going to store this value into the calculator so that we have it in hand. So ln 55 over 285, close that parentheses, divided by negative 12. Right? Or no? Why did I say negative 12? It should have been negative 20. That's embarrassing. My God. Oop. Anyways, we're going to pretend that it was 20 all along. And... oops. There we go. So, oh, that sucks. Store x, there we go. So we stored ln 55 over 285 divided by negative 20, aka my k value. Yay. After storing that k value, we are going to replace that 120, and we're going to replace it with 90. In addition to that, we are going to have e to the negative kt, because I don't know what t is. That's what we're trying to find, and I already know what k is, because k is what we just stored. 90 minus 65 is going to be 25, and we already know that 350 and 65 is 285. We're going to divide by 285 on both sides. We're going to take the ln of both sides. And then we're going to divide by negative k. So ln of 25 over 285 divided by negative k is your t value. So go back to your 84, type in ln of 25 over 285 divided by negative k, or negative x in this case. And we're going to see that it's going to take the donuts to cool from 350 to 90 degrees about 29.59 minutes. Now notice how in these examples right here, I did not turn out any intermediate steps. Since I did not round any intermediate steps, you want to round at the very, 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 very end. Or else my answer and your answers are going to be a little bit off, which means that your answer is not accurately precise. You want to be as accurate as possible whenever we are solving this. So a minute really counts. A second really counts in terms of problems like these. So just make sure that you round at the very end. Don't round intermediate steps. 3 and 4, of course, are in the student notes folder, so you guys can check that out. And then Wednesday is ACT day, so we'll only have 44 minutes together solving equations. Thursday, we have 2 hours together. And then on Friday, we'll talk more on applications in terms of half-life, compound interest, doubling formula, your basic growth and decay formulas, and all of that good jazz. But for now, work on your delta math in terms of Newton's law of cooling.